We're going to start 6.5 with a little bit of review, and the first thing I want to do is review the standard form of the line equation. And if you're not familiar with this, you might want to come in and talk to me about it, or we'll go over it in class. Standard form is when you've got the x term and the y term both on the left side of the equality and a constant over here on the right. And when you graph, you're going to want to use two of these three things, and it'll depend on what the equation looks like, which two you choose. But to get the x-intercept, the spot where you cross the x-axis, you take the constant and divide by the multiplier on x. Easy to do. Y-intercept, constant divided by the multiplier on y. Again, not a very difficult thing to do. And the slope is always the opposite of the multiplier on x divided by the multiplier on y. And like I said, if that's not something you're comfortable with, maybe you should come in and visit with me about it. Now we're going to graph the inequality that you see right here. And I'm going to take the inequality you'll see rewritten in GeoGebra, and we'll talk about what we're going to do with the inequality there. Now I think when we graph this inequality, the easiest thing to do would be use the x-intercept and the y-intercept. In order to find the x-intercept, I take 20 and divide by 2, I get a 10. So I'm going to put a dot at 10. And y-intercept, I would take 20 and divide by -5. And that gives me a -4. So when I do my graph, and I'm going to do it the same way you would do it, I would put a dot at 10. I'd go put a dot at -4. And I would take a ruler, which is better than what I'm doing, and very carefully draw the line that goes from -4 to 10. Like I said, you take your ruler and do it. Now that line is going to break the graphing plane up into two parts. There's a part above the line and there's a part below the line. One of those two parts is going to satisfy this inequality up here, and I don't know which one to do. So what I'm going to do is I'm going to choose a point in one of the regions called a test point. And the point that I'm going to choose right here is the point 0, 0. Now if 0 makes this inequality true, then what I'm going to do is shade up above the line. But if 0 does not make the inequality true, then I'm going to go shade below the line. So I put 0 in for x, 0 in for y. I get a 0 over here. 0 is less than or equal to 20. It's true. I shade up above the line. And I've got a picture, albeit crude, of the inequality. Now the next inequality I want to graph is y is less than 1/2 x minus 3. And this one I think I'm going to use slope, which is 1/2, and y-intercept, which is -3. And you're going to find that when you've got a line equation in slope-intercept form, it's easier to do than if you've got it in standard form. Alright, I've got GeoGebra all set up. Inequality I want to graph is right here. I know I've got a y-intercept down here at -3. So I'd draw that. My slope is 1/2, so I'll go up 2, or up 1 I should say, and over 2, and that would be my next point. Right there. Now, I don't have an equality in the equation, so when I graph my line, instead of doing a solid line, what I'm going to do is a dotted line. I'm going to make sure I go through those 2 points. And again, you do this with your ruler and it's going to look a lot better than what I just did. You'll do a better job. Anyway, I'm either going to shade above the line or I'm going to shade below the line. And it depends on my test point. And again, if I can get away with it, I'm going to use 0, 0. So what I'm going to test right now is I'm going to see if 0 is less than 1/2 times 0 minus 3. So I want to know if 0 is less than -3. Well, I don't think so, not in this universe. That tells me I don't want to shade above the line, I'm going to shade below the line. And that's a picture of y is less than 1/2 x minus 3. Now, most of the time, if you got the y isolated, you don't have to bother with the test point, because you know that the smaller values of y or the lesser values of y are down the axis. If you get less than, shade below, greater than, shade above. But you do need to worry about it when you have standard form. Now, the next thing that we're going to look at is really the meat of the whole section. We've got a system of 4 inequalities. There's a region in the graph that will satisfy all 4 of them. It's called the feasible region. So we're going to find that, and where the lines that create the feasible region intersect, the points are called vertices. So we're going to find the feasible region, and we're going to label the vertices. And again, I'm going to do this on GeoGebra. This time I'll do a little bit better job, because it's a little bit harder to do. Alright, here we go with the inequalities. I hope that I don't screw this up, because once you start, well, you'll see. So the first thing that I want to do is I want to take the top inequality, the one that you see up here. X-intercept is going to be at 6, y-intercept at 4. And I'm going to use that to graph the line. So I'm going down to 6. I'll click in at 6. And then I'll go to 4. And I'll click in there, and I've got my line. Now, when you do this, it's a good idea if you go and you label your lines. You're going to do a lot of lines, you're going to get mixed up, you're not going to know which one you're looking at. So I'm going to label this 2x plus 3y is equal to 12. Now the next line that I'm going to draw is y is equal to 2/3 times x. Well, that's not really very much of an issue. I just go in and I click in at the y-intercept, which is right at 0. I'm going to go up 2, and I'm going to go over 3. And I'm going to click in right there. Now the issue that I've got with this line, I'm going to get rid of what I just did. I do this all the time. Apparently I'm going to do my line again. I'm going to click in at 0. I'm going to go up 2, and I'm going to go over 3. The issue I've got with this is going to be a solid line. It's supposed to be a dotted line, so I'm going to change the properties on this. And I'm going to get the style that I want. And I'm going to close it. So I've got that line drawn. Now again, like I said, if I was a smart person, which is what I'm going to try and be right now, it's not easy for me, I would label it. So I'd label that y is equal to 2/3 times x. Okay, I've labeled both the lines that I've done. Now, my next line is going to be x is equal to 1. When you do x is equal to 1, that's a vertical line. So you cross the x-axis at 1. I'm going to click in right there. And I guess I better get my line tool first. I'm going to click in right there. And then I just go vertically to any other point that I can find, just so I get a vertical line. And then all the points on that line have x values that are equal to 1. Again, I've got no equality there, so it's got to be dotted. So I'm going to change the properties on that and change that style to dotted. The last line I've got to draw is y is greater than or equal to 0. Y equal to 0 is just the x-axis, so I've got that done. Okay, now I'm going to go back and take a look at the lines that I've drawn, and now I'm going to pay attention to the inequality. Right here I've got 2x plus 3y equals 12, and it says it's supposed to be less than or equal to 12, so I'm going to try my test point down here. And I find out that 0 is indeed less than 12. And I'm going to go up and I'm going to draw a little indication to myself that I want to shade below that line. Now I'm going to go take a look at the y is equal to 2/3 x. I want y to be less than 2/3 x. Well, I know that's below the line, so I'm going to go up here and I'm going to tell myself I want to be below that line. Now I want to be below this line and below this one, so I'm down in that region. Then the values of x that are greater than 1 are over on the left hand side, so I'm going to be on the left hand side of that. Now my region looks like this. Now y's got to be greater than or equal to 0. It means I got to be above the x-axis, and my region, this is my feasible region, is right here. Now the last thing I've got to go do is find the vertices. Now usually some of the vertices are pretty easy to find. So like right here, you know that this point is 6, 0. That banging at you here, that's my wife. And this point, where y is equal to 2/3 x intersects 2x plus 3y is equal to 12, you can see it. And that point right there is at 3, 2. So you can just label that now. Otherwise, you'd have to go and solve the system of equations where 2x plus 3y is equal to 12 and y is equal to 2/3 x. So you do a substitution, you solve it. Well, this vertice right here, I actually have to do that. I've got the line x is equal to 1 and y is equal to 2/3 x. So I'm going to solve this system by substitution. I know it's pretty easy, and it's not always this easy. Here I would just substitute a 1. I get y is equal to 2/3 times 1. And you get y is equal to 2/3. So that point right there is 1 2/3. Now I've got one other vertex right here, and this one's also pretty easy to find. You guys can just look at it and see that that's 1, 0. And this happens a lot of times. You make a good graph, your vertices are pretty easy to find, and that's 6, 5.